In this video, we are going to study about the trigonometric functions on the unit circle, and we are going to learn the values of the trigonometric functions. But before starting to that one, let me remind you about how to relate the trigonometric function with the unit circle. If you remember, we set the angle here alpha. Then there were three sides A, B, and C. When we see here, we said that opposite of alpha is equal to, and over hypotenuse, opposite of alpha over hypotenuse, it's going to be equal to, hypotenuse is going to be equal to sine alpha, or opposite of alpha, adjacent of alpha over hypotenuse, it's going to be equal to cosine alpha, if you remember. Then here, this is the relation between the sides and the trigonometry. How to carry this one on the unit circle? The unit circle means the radius is 1. So when you get a point on the unit circle, here let's say this is the point, and when you draw a line segment to the center of the circle, at the end we have this angle between them, and let's say this is also alpha. Then this is the opposite side, which is also the length here. The length is also equal to y. Here, this is the y value of the point, and this is the x value of the point it's going to be, and the coordinate of this point x and y is going to be. Then we know this is 90 degree, and we know that sine alpha is equal to opposite side over hypotenuse, it's going to be. And in the unit circle, when the radius is 1, sine alpha is equal to the opposite side, the length, it is y, and the hypotenuse is 1, that's why sine alpha, it's going to be equal to only y, which means on the unit circle, always the y values are, on the unit circle, y values are sine alpha. So y is equal to sine alpha, it's going to be, or for the cosine alpha, which is adjacent over hypotenuse, which is equal to x over 1, then this is equal to cosine alpha is equal to x value. So when I write the coordinate of the point, I can write like this. If x is equal to cosine alpha on the unit circle, this is going to be cosine alpha, and this is going to be sine alpha. So here, the first length here, this is going to be cosine alpha, this is cosine alpha, and the second length, which is here, the second length, and which is on the y-axis, it's going to be sine alpha. Okay, with respect to that one, here there are in 4 quadrant the sine values are shown, and there are some extra informations about the sine alpha. Firstly, in the first quadrant, sine value is here. This axis called at the same time sine axis in the trigonometry. So the radius is 1 here. These are all unit circles. In the first quadrant, the angle is in the first quadrant. In the first quadrant, sine alpha is positive. Sine alpha is positive, greater than 0. In the second quadrant, this is the second quadrant, but for finding the sine alpha, you should find the length of this part. So this length, again it is positive. So sine alpha is greater than 0 again. In the third quadrant, the alpha is here, then the sine alpha becomes this value. And this, if this is y-axis and if this is x-axis, the values below the x-axis, it's going to be negative. That's why here sine alpha is smaller than 0. sine alpha is smaller than 0. In the fourth quadrant, sine alpha is again smaller than 0, as you see. And we are going to get the sine alpha between -1 and 1 firstly. And this is the last one about the sine alpha. When you increase in the first quadrant, sine alpha is also increasing. As you see here, the sine alpha value is increasing. When you continue to increase the angle, after 90 degree, sine alpha starts to decrease. Here it's getting decreasing the sine values here. Think about these values. Sine values are decreasing and it becomes 0 here. Then at this point, after this point, it's increasing but negatively. So it continues to decrease. Decreasing. After this part, it's starting to increase again. So, but here, as I said, here it is negative, here it is negative. So in the third quadrant, it is negative. In the first and second quadrant, sine alpha is going to be positive. Okay, let's continue with the cosine. Cosine axis is the x-axis. So this axis is the cosine axis. So I'm going to check the value here. When I get the angle, the value here. So the value here, it is positive. The value here, it is negative. The value here, it's still negative. And the value here, it is positive. So cosine alpha in the second quadrant, it is in the first quadrant, sorry, cosine alpha is greater than 0. In the second quadrant, cosine alpha is greater than 0. I'm sorry, it is smaller than 0 in the second quadrant. In the third quadrant, cosine alpha is greater than 0. No, again mistake. It's smaller than 0. And the last quadrant, cosine alpha is greater than 0. Here, like in the sine function, in 2 quadrant it is greater than 0. In 2 quadrant it is smaller than 0. And also one extra information here again, cosine alpha is getting value between -1 and 1. So for the values greater than 1, cosine alpha is not defined. Okay. Tangent function. Here on the unit circle, we have the value on the unit circle here for sine and cosine. But when we are talking about the tangent, we are drawing a line segment that is parallel to y-axis. That's why it is called tangent axis, because this line is tangent to the circle. Then the length here between the x-axis and the intersection point of the ray, it is called tangent alpha. It is the length of tangent alpha. And tangent alpha, it's getting its values between -infinity and infinity. This is the last one. When you draw your here, as you see here, when you draw your tangent line to the perpendicular to y-axis, which is parallel to x-axis, the line segment here, the length of the line segment here becomes cotangent of alpha. Cotangent of alpha. And here this length is cotangent alpha. Okay, what about the cotangent alpha values? Cotangent alpha values are positive. It's going to be positive infinity and negative infinity. It's going to change between positive infinity and negative infinity. Here there is another reason for the also sine alpha and cosine alpha. They are between 1 and -1, because sine alpha, if you remember, it is opposite of alpha over hypotenuse. And hypotenuse always greater than opposite side. So this fraction, this ratio, always denominator is greater than. So if you remember, it is called here, this one, when the numerator is greater than denominator, when the numerator is greater than, when the numerator is smaller than denominator, this is always going to be smaller than 1. And if we show them all together here, when I get one angle here, I want to show sine 56 and cosine 56, all of them together on the unit circle. Here, when you choose your angle, let's say this is alpha, and now when I choose 56 degree, or I can change that one, let's say 49, that's not important exactly. Here, this is the angle, and as you see, the length here on the sine axis, it is called sine alpha. The length on the x-axis, it is called cosine alpha. Tangent line perpendicular to x-axis is tangent alpha, and as you see, it is greater than 1. Here, this length, as you see, it is greater than 1, and we know that this length is 1 also, because it is equal to radius. And cotangent alpha, look at the cotangent alpha. Cotangent alpha is smaller than. When you come to 90 degree, here, I couldn't check to 90 degree, sorry, yeah, here it is. Sine, cosine, we have here, sine is equal to here, the longest length, and it is 1. What about the cosine? Cosine is here also, cosine is 0. Here tangent is this line, and this line is parallel, that's why they are not intersecting. Actually, this value is infinity, and this value is 0, because here, as you see, the tangent, well, the length is 0, it's going to be. If I continue, in the second quadrant, as you see, cosine is negative, sine is positive. So tangent and cotangent, they are going to be negative. In the third quadrant, sine and cosine, sine is negative and cosine is negative. Tangent and cotangent, they are going to be positive. In the fourth quadrant, sine is negative, cosine is positive. So tangent and cotangent, they are negative. By the way, we are going to learn these things in the trigonometric identities part, but here sine alpha over cosine alpha, it's tangent alpha, and cosine alpha over sine alpha is equal to cotangent alpha. So when this is positive, then this is negative, this value it's going to be negative. Or when this is negative, this is positive, again it's negative, it's going to be. Here, if they are both negative, this one is negative, this one is negative, then cotangent value it's going to be positive. That's why I said here, here, when you change the angle, let's say one sine is positive, cosine is negative. So tangent and cotangent values, they are going to be negative, because tangent is sine over cosine, positive over negative. Cotangent is cosine over sine, which is negative over positive. So both of them, they are going to be negative.